In this paper, we propose a simple yet effective method termed FreeU, which enhances generation quality without additional training or fine-tuning. Diffusion probabilistic models have garnered significant attention, particularly for tasks related to computer vision, for example, image and video generation. Existing studies focus on utilizing pre-trained diffusion units for various applications, while the internal properties of the diffusion unit remain largely underexplored. First, we delve into the denoising process of the diffusion unit. We conduct an investigation within the Fourier domain to perspective the generated process of diffusion models. We can see that the gradual modulation of low-frequency components showing a soft rate of change, while their high-frequency components show more obvious changes throughout the entire denoising process. We further visualize the relative log amplitudes of Fourier for denoising process. Low-frequency components provide the basic structure and colors of an image, while high-frequency components, representing details like edges and textures, are more prone to noise. The purpose of denoising is to minimize noise and preserve these essential details. So how diffusion unit implements denoising process? The unit architecture contains a backbone network and the skip connections. We apply two scaling factors B and S to adjust the feature maps from the backbone and skip connections before concatenating them. We can see that increasing the backbone scaling factor B significantly enhances image quality, while directly scaling S in the skip features has a limited influence on image synthesis quality. A commensurate increase in B correspondingly results in a suppression of high-frequency components in the images generated by the diffusion model. This indicates that the main backbone of the unit primarily contributes to denoising. Conversely, the skip connections can introduce high-frequency features into the decoder module. These high-frequency information make unit easier to recover the input data during training. However, this can inadvertently weaken the backbone's denoising ability during inference. Hence, we introduce FreeU, a method that improves generation quality without extra training. It uses two modulation factors during inference to balance features from the unit's backbone and skip connections. To enhance the denoising capabilities of the unit, we introduce a novel method known as structure-aware scaling for the backbone features, which dynamically adjusts the scaling of backbone features for each sample. Our approach adjusts the scaling factor adaptively based on the specific characteristics of the sample features. However, we find that while the inclusion of backbone feature scaling factors yields significant improvements, it can occasionally lead to an undesirable oversmoothing of textures. To mitigate the issue of oversmooth texture due to enhancing denoising, we further employ spectral modulation in the Fourier domain to selectively diminish low-frequency components for the skip features. We systematically conduct a series of experiments, aligning our benchmarks with state-of-the-art methods such as SDXL, ControlNet, LCM, ScaleCrafter, DreamBooth, AnimatedIF, ModelScope, Reversion, and ReRender. Thank you for watching.